that one 1680 can be written as 8 times of 210, right? And 210 can be written as 7 into 1680 can be, okay. Now option 1680 can be written as 8 times of 210, where 210 can be written as 7 times of 30, where 30 can be written as 6 times of 5. That means 1680 can be written as 8 into 7 into 6 into 5, which is equal to 8p4. By comparing, n value is equal to 8. Okay, next problem, fifth one. What is observe that fifth problem on the screen? Observe that fifth problem on the screen. The number of different signals that can be made from 5 flags, right? From made by 5 flags from 8 flags. Okay, that means n value is equals to the highest value should be n value and r value is equal to 5. Okay, that means required arrangements is equals to npr, which is equal to 8p5. Okay, what is the value of 8p5? 5 consecutive terms back, 8 into 7 into 6 into 5 into 4. Simplifying this, we are going to get 6720 as answer, right? And observe that sixth problem on the screen. Observe that sixth problem on the screen. Of course, I am going to give you time to copy this one, but just observe the sixth problem. A man has 4 sons and there are 5 schools within his reach. Find the number of ways he can take the admission such that no two sons will be in one school. That means n value is equals to 5, r value is equals to 4. The npr value is equal to 5p4, which is equal to 5 into 4 into 3 into 2, right? Which is equals to 120. Understood? Now copy these 3. After copying this, let us go to the 7th problem. Yes, copy these 3. I hope you have copied it right. And now the next one. Yeah. Yes. Observe that seventh problem. Observe that seventh problem on the screen. The number of 3-digit numbers using 1, 2, 3, 4, 5. If no digit is to be used more than once, means repetition is not allowed. Okay. How many numbers given to you? Given digits is equal to 1, comma 2, comma 3, comma 4, comma 5. That means n is equal to 5. He asked you 3-digit number 1, 2, 3. 3-digit number occupies 3 places and it can be filled in 5 ways, 4 ways, 3 ways. Okay, so NPR is equal to 5P3. Simplifying this, we are going to get 60. And see that problem number 8 on the screen. See that problem number 8 on the screen. Using the digits 0, using the digits 0, 2, 4, 6, 8, not more than once in any number, the number of 5-digit numbers that can be formed. Number of 5-digit numbers that can be formed, he asked you. He has given you 0, 2, 4, 6, 8. He asked you 5-digit number, right? 5-digit number occupies 5 places. Observe 1, 2, 3, 4, 5. Here, you should not fill up this with 0. Okay, so one number gone and one place gone means you will have four choices to fill. So you can fill up the first place in 4 ways. Now one number and one digit gone. Therefore, there will be 4 places and 4 digits. You can fill up this in 4 ways, 3 ways, 2 ways, 1 way. So 4 into 24 is equals to 96 ways. I am repeating this again. You should not fill up this with, he asked you 5-digit number. In 5-digit number, the first place should not be filled with 0. If you fill this with 0, this becomes 4-digit number. Hence, this should not be filled with 0. You can fill this other than 0 in 4 ways, right? Either 2, 4, 6, 8. Okay. Now you can fill up this one with 4 ways, 3 ways, 2 ways, and 1 way. Total permutations are 4 into 4 into 3 into 2 into 1 is equal to 96. And the 9th problem, observe number of permutations that can be made using all the letters of the word matrix. M-A-T-R-I-X. First of all, after seeing the word, you should check whether any letter has been repeated or not. In this word, no letter has been repeated. So we should fill up, that means we can arrange all the letters of the word. Here we are having 6-letter word, okay, by taking all. R value is also 6. So NPR is equal to 6P6. NPN is equal to 6 factorial, okay, which is equals to 720. I hope you understood my point and observe the 10th problem on the screen. Observe the 10th problem on the screen. Number of 4-letter permutations that can be made from the letters of the word triangle. In the word triangle, that means the word triangle consists of triangle consists of 8 letters. In those 8, no letter has been repeated. So he asked you a 4-letter word. So R value is equal to 4. Okay. Now, how many 4-letter words can be formed by using the letters of the word triangle? 8P4 is equal to NPR. What is the value of 8p4? 8 into 7 into 6 into 5. Copy this one. Yeah, copy these 10 problems. I hope you are copying it. Yes, I hope you have copied it. Now, observe the next problem on the screen. Problem number 11. Number of arrangements that can be formed by taking all the letters of the word T-E-N-A-L-I, Tenali, that are to begin with T. That means the word should begin with T, right? Right? And observe that 11th problem on the screen. Number of arrangements that can be formed by taking all the letters of the word that begin with T-E-N-A-L-I, right? The word should begin with T, means you can fill up this in only one way, right? And the remaining five places are there. You can fill up this in 5 ways, 4 ways, 3 ways, 2 ways, and 1 way, which is equals to 5 factorial into 1, which is equals to 120, right? And observe that 12th problem. the letters of the word article, A-R-T-I-C-L-E, the letters of the word article are taken 4 at a time. He asked you to write 4-letter word, okay, at a time and arrange it in all possible ways. The number of arrangements consisting of I, that means containing I. See, he asked you 4-letter word. 4-letter word occupies 4 places, right? In each and every word, whatever you are going to take, in each and every word, you should have a, right? That is the meaning of the question. So, article 1, 2, 3, 4, 5, 6, 7. It is a 7-letter word, right? It is a 7-letter word. N value is equals to 7. Now, A can be written here one way. It is here. A can also be here. Can also be in the 3rd place. Can also be in the 4th place. So, 4. I am repeating. Actually, what is the meaning of the question? Whatever you write a word, whatever you form a word by using this one, whatever you form a 4-letter word, in that 4-letter word, there should be capital A, right? So, A can be in the first place. We can take some words where A can be in the first place, right? We can also take some words, we can also form some words where A can be in the 2nd place, similarly 3rd place and the 4th place. So 4 into, right, one place will be occupied by this capital A, then there will be only 3 places, 1 letter gone, so there will be 6 letters, so that can be arranged in 6p3 ways. So 4 into 6p3 is equal to 4 into 6 into 5 into 4. Understood? 20. 6p3 value. 6 into 5 into 4. Okay. I am repeating. Here, A should be here, right? I think he asked you 4-letter word. Whatever you form a word, in that word, A should be there. So, A can be filled here, 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 that is 4 times. 1 letter gone, there will be 6 letters and only 3 places. It can be filled in 6p3 ways, right? So, you can multiply this one and you can give the answer, right? Next, 13th problem. Observe. The answer, I think it is 480 you should get. Now, see that 13th problem on the screen. The number of arrangements which can be made out of the letters of the word Kanpur, Kanpur, without changing the relative order of vowels and consonants, right? You should not change the order of vowels and consonants by taking all the letters of the word, right? See here, Kanpur. 1, 2, 3, 4, 5, 6. It is a 6-letter word. Here, how many vowels are there? 2 vowels are there. So, A, U. The 2nd place and the 5th place should be filled in 2 ways. Why? Because you can interchange them. 2 ways into remaining 1, 2, 3, 4 can be filled in 4 factorial ways. 4 factorial is equal to 24 2s are 48. I am repeating this. Kanpur consists of 6 letters. He asked you the relative positions of vowels should not be changed. Means A can be written, that means whatever you frame a word, here you can get U, but you should not get N in the 2nd place. You can get A, but you should not get P in the 2nd place. Means relative positions of vowels should not be changed. means in the vowel place, here it is vowel place now. In the vowel place, only vowel should come. How many vowels are there? 2 vowels are there. So they can be arranged among themselves in how many ways? 2 factorial means 2 ways. And there will be 4 places again. In 4 places, 4 letters can be arranged among themselves in 4 factorial ways. 4 factorial is equal to 24 into 2 is equal to 48. Copy this one. Yes. Copy these 3. I hope you have copied it. Now, problems on repetition of things. I am going to recall the concept of repetition is allowed. Okay, that means from 14th problem, repetition is allowed. When repetition is allowed, how to do? From 14th problem, repetition is allowed. Okay, among n things, r things are taken and arranged in n to the power of r ways when repetition is allowed. When repetition is allowed, right? And n to the power of r minus npr ways when at least one is repeated. When at least one is repeated, it is n to the power of r minus npr, right? Now, see that 14th problem given, that means on the screen. I am going to share the screen now. The number of 3-digit numbers. Wait for a while. Yeah. I hope it is visible to you. The number of 3-digit numbers that can be formed using 1, 2, 3, 4, 5 any number of times means repetition is allowed. When repetition is allowed. So see that 14th problem I am going to do on the board. Given digits is equals to 1, 2, 3, 4, 5 means n is equals to 5. Required digited number r is equals to 3. Right? It is 3-digit number he asked you. Right? So observe 1, 2, 3. It is a 3-digit number. Repetition is allowed. So you can fill up this place in 5 ways. 1, 2, 3, 4, 5. Suppose if I fill this with 3, you can also fill this with 3. Why? Because repetition is allowed. So it is of 5 times, it is of 5 times. So 5 into 5 into 5 is equal to 5 cube. It is 125 times. Right? See, observe that 15th problem on the screen. 14th completed. 15th one. The number of 4-letter words, number of 4-letter words that can be formed using the letters of the word explain. EXPLAIN, right? It consists of 7 letters using which begin with an vowel when repetition is allowed. Okay, so he asked you a 4-letter word, am I right? Yeah, he asked you number of 4-letter words. So see here, 1, 2, 3, 4. 4-letter word occupies 4 places. E, A, I. There are 3 vowels, so this can be filled in 3 ways. Right? The word should begin with vowel, means it can be filled in 3 ways, right? And you can fill this in 7 ways. Why? Because 7-letter word. Suppose if it is filled with I, you can also fill this with I. Why? Because repetition is allowed. And you can fill this in 7 ways, 7 ways. Means 7 cubed into 3 is the answer. Copy this one. Now, 16th problem is on the screen. Observe that 16th problem. 8 different letters. 16th problem. 8 different letters means n is equal to 8. Of an alphabet are given. Words of 4 letters from these are formed. R value is equals to 4. Right? The number of such words with at least 1 letter is repeated. At least 1. N to the power of R minus NPR. That means 8 to the power of 4 minus 834. Simplifying this, you are going to get the answer. Copy this one. Yeah, copy this up to 16th problem. Over. Next problem. Yeah. See that 17th problem on the screen. 17th one. A letter lock consists of 3 rings marked with 5 different letters. Number of maximum attempts to open the lock. That means there are 3 rings, right? There are 3 rings. Each ring can be turned 5 times as it is up to the matching of that number. So 5 into 5 into 5. 5 into 5 into 5, which is equals to 125. Copy that one. 17th problem. Write down. I am repeating the explanation of 17th one. There are 3 rings. Means you just take 3 places. From those 3 places, each place can be filled in 5 times. Why? Because the number can be repeated. Right? So 5 into 5 into 5, it is 125. Next problem. 18th one is on the screen. Observe. Problems on functions and its applications. Already functions chapter has been completed to you. Number of functions from set A containing 5 elements to set B containing 4 elements is equal to. That means according to our functions chapter, I am going to do on the board. Observe. Problem number 18. Number of A is equals to 5, which is equal to M. Number of B is equal to 4, which is equal to N. Total number of functions from A to B is equal to N to the power of M, which is equal to 4 to the power of 5. We learned in your functions chapter, right? See that 19th problem on the screen. The number of injective functions or injections from set A containing n 5 elements. M is equals to 5, n is equals to 6, right? Therefore, npm, which is equal to 6p5. That is total number of injective functions or injections from A to B. Okay. Next, where here it is m is less than n, m is less than or equal to m. M value is less than or equal to n. It is npm. Suppose m value is greater than n, it is 0. Okay, you should take those two. Next, see the 20th problem on the screen. The number of onto functions that can be defined from capital A. How many digits are there? See here, how many elements are there in set A? Set A consists of 5 elements, right? Set A consists of 5 elements, right? So A, B, C, D, E. Number of A is equals to 5, which is equals to n. Okay. Number of B is equals to 2. So total number of onto functions from A to B or surjective functions from A to B is equal to 2 power n minus 2. So the answer is 2 power 5 minus 2, which is equal to 30. Copy this up to 20. Yes, I hope you have completed that 20. Okay, tomorrow let us do some more problems. Thank you. Have a nice evening.